Please also tell a little bit about what kind of problem we are solving using YOLO.
Yes, ma'am. Very good evening to all the participants. In today's lab session, we are going to have a hands-on session with YOLO. So YOLO was first started in 2016 by Redmond et al. They have developed the YOLO version 1, followed by 3 other versions, 2 and 3, YOLO 1, YOLO 2, and YOLO V3. Then due to some ethical reasons, they left the object detection task. And then to continue the work, YOLO V4 was launched by LXC B. And then there are some unofficial version of YOLO also available, like YOLO V5, V6, and V7. But after YOLO V4, the latest version is YOLO V7 by the official author of YOLO. So we are working with YOLO V4. Later on, if needed, we can go ahead with YOLO V7 also, that because it is a latest one. So instead of going to that, we are giving the glimpse of the backer, that YOLO version. So that is the official one. YOLO V4 is the official one. And then YOLO V7 is the latest launch. If you want to work to YOLO V7 also, then we can help you with that also. You can go through the folder shared with you, and then you have to go to day 10 lab session. Either you can download this dataset.zip. If you have enough internet availability, it is just 43 MB size. If you don't have the internet capabilities to download this much of file, then we will try to share the dataset with you in the same way we have done earlier. So other than that, we have also shared this YOLO V4 word detection file with you. This is a simple instructions file with all the steps available in it, how you can train the YOLO V4 for your custom dataset. So as explained by Santosh sir, YOLO is a single stage object detection method. Other than this, you can also use RCNN, faster RCNN for as two-stage object detection, or the recent one are RetinaNet, M2DET, EfficientDET. Many other models are there for object detection task. So here we are using this particular YOLO V4 for word detection. This is like, because we have to complete it within 2 hours. So this is having a very small data set. But here in our institute, we are using object detection for specifically, if you will talk about my research problem, we are using it for disease localization task, where we have collected the data through drone, then we have labeled it, and after that we have trained YOLO V4, faster RCN, and M2DET for localization task. So I think in the theory part, somebody was asking how to label your custom dataset. That also we will cover. So earlier I have trained this particular notebook up to 2000 iteration. That is the reason in my official ID I don't have sufficient GPU capabilities. So I am switching to my personal ID, and then in the same way you can also do the things with me. In between, if you have any doubt, you can interrupt us, and then we will try to clear your issue. So go to your drive and create a new folder. I'm creating day 10. Inside that, we will create the Python notebook. So before going to create the notebook, let me explain the dataset and how you can label the dataset. So for labeling task, we are using label IMG tool. I'll send you the link. So this is the Python package. Other than that, this is the official GitHub package. So this is an open access tool for labeling your data, where you can create the bounding boxes over the object and you can annotate it. You can save the annotations in two formats. One is XML, that is generally used for annotation in XML based hierarchy. And the second one is the YOLO format. So I'll explain you what is YOLO format, and then I'll have a basic introduction how you can use label IMG tool. So for installation, you have to install it in offline mode in your local system. So you must be having Python in your system, and then using pip3 install label IMG, you can install it in your local system. Suppose you are having Jupyter already installed in your system. So I'm opening Jupyter Notebook. If you also have it, please open it. And meanwhile, I'll copy the link of the tool in the chat box. You can go through the documentation of label IMG for custom dataset labeling. In my case, I am going through. I'm opening one Python notebook in my local system. So if you want to install label IMG, you have to write pip install label IMG. So it is saying that requirement is already satisfied because I have already installed label IMG in my local system. And then to open it, you have to just write label IMG. So when you run it, label exclamation mark label IMG, it will open one software. You can see a new window is here with label IMG tool. So this is the entire structure. This is your file menu where you can open the image directory as well as the directory where you want to save the annotations. This is to create the rectangular boxes, and other options are there that we can use. So by default in my case, when we use it for labeling, we enable autosave, single class mode, display labels. These advanced properties we have enabled. So let me tell you how you can label any of the object. So first of all, you have to either open an image or a directory. So we are opening a directory. In Asia Connect, I have created one folder. This is the folder. In place of that, let me open. I'll take some images from the data set. I'm creating one folder, dummy. And then I will open it. It is having some, here we have copied 4 images. And then we have to open dummy folder. So we are selecting it. Then it will change the save directory. The second option is, I don't know why it has closed. Let me rerun it. So open directory in place of dataset, dummy. I don't know why, maybe some memory issues are there. That's why it is closing again and again. So in place of dummy, this time I'll open the dataset itself. Open directory, dataset, select folder. Hopefully this time it will not. So it is saying it doesn't have a text file. classes.txt. So I'm just writing class name as Word. I don't know why yesterday it was working perfectly. Maybe I'm doing something wrong. So you have to just open label IMG tool and then open the directory. So in place of data set, I'll open dummy, select folder. Again, it is closing. It is restarting again and again. So I'm opening one image from the folder. I don't know why it is happening. Maybe because of some RAM issues, it is not allowing me to. Because I have created classes.txt also. Then also it is closing. If I'll run in capital also. Let me check how. No, it is closing again. So no issues. I'll tell you from here. I will close the Jupyter notebook again, maybe. This could be because of notebook also. So on desktop, I'll go to Asia Connect and I will open a new notebook. This time we are trying it like at the last time. If this time also it will not work, we can go ahead with other part. So I have to open label IMG. Open directory. I'll open dummy, select. It will close again. No issues, let it be. I'll explain you through the web only. So this is the interface where you can open directory and open the save directory where you want to save the annotation. So if you want to save in the form of Pascal VOC, it will be saving in XML format. But if you want to save it in the form of YOLO, then it will be saving in the form of .txt file. So for each image, a corresponding .txt file will be there. You can see the name of the image as well as the name of the annotation file should be same. For each image, there is a corresponding text file that is annotation. So suppose this is the image. So here you will having the box above the bird with some class. And this is your annotation file. So suppose in a single image, if there are more than one objects, or you can say more than one bounding boxes, so each bounding box will be separated by a new line. There are 5 annotation elements. The very first is this 0 defines the class. 0 means you are talking about the 0th class. Other 4 are the bounding box definition. That means these 0.52 and 0.57. These are the center coordinates of your object in entire image. And these are the height and width of your object. So suppose there is another element with class 5. So in the next line here, you have to write 5. That will be done by label IMG tool 5. And then 4 other elements will be there. That will be defining your X center, Y center, width and height of your bounding boxes. So these bounding boxes are normalized by dividing the height and width of the image. So now let's talk about the data set. So here we are using this CUP 2011 data set, which is having total number of 200 categories of words and total 11,788 images. They have collected the data set from various locations and then labeled it. They have labeled it and provided you. You can download the images as well as the corresponding annotation from here. If you want to work on the segmentation part of the same data set, you can also download the segmentation of the corresponding images. So I'm pasting the data set path. Because it's a huge data set, total number of categories are 200 and number of images are 11,788. We cannot complete it within 2 hours. The training will take a lot of time. So we have selected some 10 classes, initial 10 classes from the entire data set. If you want to, I have the entire data set also downloaded. If you want to work with that, that also we can provide to you. And the classes are also there. All the 200 classes are annotated over there. So we are using 10 classes with all the images on these 10 classes, which are some, I think 534 images. So we will work with that. We have already trained the YOLO V4 model because that took around 5 to 6 hours to train it for 2000 iteration and achieving the minimum loss. So that is also again not possible. So we will share the trained weights with you as well as the entire data set if you want to work with this complete data set for word detection. These are the instructions. This is the link of this notebook has been already shared with you. This is the link for label IMG tool. Let's begin with the deployment part now. I think I've already opened. This is the place where, so I'm closing the other files. So now please start with me. I request you all to please have a hands-on session on this object detection. It's little lengthy but easy. Once you will be having the all the files ready, you can go ahead with us. So all please create a new notebook by clicking on this plus menu. Go to more and open a Google Collaboratory. All of you please do this with me. In between there is any issue, let us know. Whatever issue you will face, whether it is about creating the files or accessing the dataset, we will try to resolve it. So I have created one new notebook named as word detection. Next part, because it's a object detection task with images, you instead of CPU, you will definitely needing GPU or TPU. So we are setting the runtime. Go to this runtime option, change the runtime type from none to GPU and save it. In my official ID of triple IT, I have exhausted the limit of GPU. So there are chances that in your case, if in earlier labs you have used GPU, so you can also have limit to CPU only. Now we have changed the runtime. Next option is you have to connect to the cloud server of Google. So I'm connecting. After this, you have to mount your drive. So I'm clicking on mount drive. All please do the same and click on connect to drive. So till now, we have not uploaded any data set. If there is any network issue, we will directly access it through the drive earlier we have done. So I'm going to a place where this particular notebook we have created. So in my drive, I have created it in day 10. Day 10, I'm copying the path by right clicking on day 10 folder, then click on copy path, and then %cd is the path, change the current working directory. So in your case, path will be little different. And then I'm running ls command to list the files in directory. So there is only one file, that is birddetection.ipynb. Next is we have to work with the official code of YOLO v4 that is developed by LXC. So I'll search for LXC Darknet YOLO v4. It will give you some GitHub link, so I'm giving you that too. And this is Darknet. You can see there is another, let me give you first this GitHub link of LXCAB. There are one version of Darknet, and this is another, the latest one of 2023, that is YOLO v7. So from YOLO v4, they have directly switched to YOLO v7. This is the complete code, which is written in C, C++, Python, all the required languages. And these are the instructions. So you can see from YOLO v4, they have given YOLO v7. You can read it out. And then this is the documentation. So it is in PyTorch. The current one we are using is in basic Python, C, and C++. You can go through the documentation if you want to work with YOLO v4 or YOLO v7 documentation is there. So this time we are working with YOLO v4. You have to clone it. If you are working in collaboratory environment, you have to clone the complete code. So I'm clicking on this code and copying the path. And then I'll write git clone. So it is cloning or downloading the Darknet. I will copy the code in the chat box. All of you, please run it. In my case, cloning is done. When the cloning will be done, and you will see in your current working directory, either in Drive or with ls command, you will find out a new folder will be there with name as Darknet. It will be having various make files, other configuration, and some folders are there, which will be needed when you are working with the custom object detection that we are going to do next. All of you, please do up to this particular part. I'll wait for you. Please report in the chat box if you are working with me. If you will be done with the cloning, please write cloned. First of all, you have to change the current working directory. Then in the directory, wherever you have moved, write git clone and then path of the GitHub link. You have to just write git clone and then this is the path. I have pasted the path in the chat box, or you can search for LXCAB git darknet. And then you have to clone the darknet. When you will be cloning the darknet after the successful cloning, you will be having darknet folder. Go inside the folder. We have to work inside this particular folder. After cloning, please comment this line, because once you have cloned the darknet, no need to download it again. So I'm commenting it. For Python commenting, you can use Control/button. It will comment your lines. So whichever lines which you have to only run once, we can comment it so that if there is any discontinuity or you will be disconnected from your internet and you rerun it, no need to run the command again. Like no need to run these command again. Otherwise you will encounter any error. Next is currently we are in day 10 folder. Now we have to go inside darknet. So for that, I am writing cd space darknet. The next, after cloning, you have to change the current working directory from day 10 to darknet. So just cd space darknet. So when you will see inside the darknet folder, there is a one file, make file, which can be helpful to make the executable build of your entire code that you have cloned. To make the executable build, you have to make some changes in this make file. This is a, you can see it is showing binary file. You can either download this particular file, make the changes and upload it again. One way is just right click on this file, download it, make the changes at 3 places. You have to make the changes. I'll explain both the way. So I'm downloading it. So what you have to do? You have to make GPU 1, CUDNN 1, and OpenCV 1. GPU 1 means you are enabling GPU, graphics processing unit. CUDNN is another library which helps you to use the properties of your GPU or hardware. And then OpenCV because you are working with images. Save this file and then upload it again in the folder. This is one way. The other way I'll explain you, but there is a question if you are working with Jupyter Notebook in offline mode. You are getting Git is not recognized because Git is Linux based command. You cannot run it if you are working with Windows as your operating system in offline mode. So if you are working with Jupyter Notebook with Windows, don't do like instead of doing it offline. I suggest it's better to work with collaboratory notebook. If you want to work with Windows platform, you can directly download it. But then also there are various commands that will be not working. You can click on this code option, download the zip file. But again, when you run the next command that we are running, that will also not work if you are Windows platform user. So after running this cd command, either download the make file or make the changes here using sed command, that is a Linux based command. So I'm using this sed-i. It will search for GPU is equal to 0 and make it GPU is equal to 1 ht in make file. This is the other way. Using sed command also you can change the lines. You can enable CUDNN, GPU, and OpenCV. So again, after running these 3 commands, have to comment these commands. I'm selecting using // to comment these 3 lines. So what you want to know, what is %cd? We are changing after cloning the darknet, we have to go inside the darknet folder to make the changes in make file. For that, you have to run cd command, cd space darknet. These are the basic commands of any operating system. cd is change directory and then name of the directory. Then SCD we are using to make changes in the make file. Make file is available here. Make file, either download the file, make changes in first, second, I think fifth line, from GPU 0 to GPU 1, CUDN 0 to CUDN 1, and OpenCV 0 to OpenCV 1. If you are able to run up to this part, please let me know so that we can go ahead. Okay. The next is you have make the changes in the already made the changes in the make file. The next thing is you have to make the executable build of your entire code that you have downloaded through the git clone command. So for that you have to run make. So if you are working offline in your Windows OS, you cannot run this. Make is not supported in Windows. It will take some time to make the executable build. All of you, please run this command. After SCD command, you have to run make command. So till this part, what you have done, you have changed the current working directory, then you have cloned the darknet from official website. After that, you have to go inside the darknet folder. Then you have to make changes in the make file. 3 changes are there. Make GPU 0 to 1, CUDNN 0 to 1, and then OpenCV 0 to 1. After that, you have to make the executable build of your downloaded code. For that, make command is there. It is again Linux based command. It will take some time. All of you, please do it. Then we will go ahead with the data set and required files preparation that is needed for custom object detection using this darknet clone. When you are done with this make, please report in the chat box. Okay, in your case, cloning is done. Anyone who is getting any error when you are running make command? In my case also, make has been executed successfully. I'm closing the output and then commenting this make command, control/, because once you have created the executable build, no need to rerun it. Ignore the warnings. If you are getting any warning, not error, then no issue. And if you are getting any error, like you are getting chmod +x sh, no rule to make target object image OpenCV needed by darknet. Please check your make file has changed successfully or not from 0 to 1. It's %cd. You are using scd command not found. It's %. It's not s. It is %sign. the use of make command is to create the executable build that you have downloaded from the git clone command. M is small. Don't write M capital if you are writing make. SED is here. Please check you are using SED or SCD, because earlier Radha Krishnanji, earlier you have write SCD. It's SED first of all, or %CD. So now let's access the data set. Anyone from the participant can respond, like what is the number of classes in the data set we are working with? I have already explained you the data set. Anyone from the participant can write. Okay, for in 10 classes in the data set, either you can upload, we have already shared with you, or the second one is the way I am using. I'm opening my drive where I have uploaded. So this is my official ID. And currently I'm working with my personal ID. I have already done the same part. So I'll share the dataset folder that you have to use. If you are unable to upload it. I think all of you are able to at least open the link. If you are not able to copy it, at least you can, by clicking on the link, you can copy it. Just open the link. I have just now pasted in the chat box. Open the link. Then you have to add the shortcut of this particular folder. You can see add shortcut is there. The place where you have cloned the darknet. Make sure you are creating the shortcut at the correct place. I'm going to my drive, then day 10. Inside day 10, you can see darknet is there. I'm clicking on going inside darknet, and then I'm adding shortcut inside darknet. All please do the same. Click on the dataset folder. You can see dataset is written here. I'm clicking on it. Then I'm clicking on add shortcut to drive. Please listen it properly so that you can access the dataset. click on the data set, add shortcut to drive, go inside my drive, go to the place where you have cloned the darknet, go inside darknet, and then add the shortcut. So now I can access this particular data set in my day10. Inside day10, there will be a shortcut. You can see data set shortcut is there. In the same way, you will also be having the shortcut. When you will be clicking on this data set, you will find out all the images are there with the corresponding bounding box annotation. So there are total, I think, 534 images in 10 categories. We go ahead. All of you are able to access the data set. Please write in the chat box, or there is any issue. Because up to this part, if you are able to do properly, it will be helpful to go ahead with the other configuration part. Okay. Next is, you have to split the data set. Earlier also you have done the splitting of training and validation and testing. So this time we are splitting for training and testing. So YOLO reads the training files and test files from a text image. So it's from a text file. All the image name should be there in train.txt and test.txt or anywhere in your darknet folder. You have to give the path of the train file and test file, which will be having the name or path of your images. Either you can create these files manually or through the code. So I'm creating through the code. What we will do, we will assign 80% of the images for training and remaining 20% for testing. So I'm writing the code. It is a basic code to split. We will read the image name from the dataset folder, and then the initial 9 files we will assign to, like initial 8 files we will assign to training and the remaining 2 for testing. Like that we will do. Or you can create your own code if you want. So first of all, check dataset is there or not. Dataset is there. Let me first of all I'll copy this because I think I have added twice the name of the folder. When I will run ls space name of the folder, that is dataset, it will give me no such file or directory. Okay, now I have dataset. When I will be running ls dataset, it will show all the text file and images names. You can see all the images name and text file names are there. You can also run ls dataset to check whether you have successfully added the shortcut or not. Then one by one, we will read the images name and then make two files. One is train.txt, one is test.txt, and then we will do the splitting part for training and testing. So for that, you will need two packages. One is globe and one is OS. OS is the operating system based commands. So the main directory is dataset. Then you have to define the percentage of test you want to give. So 20% we are giving for testing. Then using the basic file command, we can create two files. Train file, open. So we'll create these files inside data folder in the darknet. We will create it inside this data folder. Inside data, I'm creating train.txt with write mode enable. Similarly, I'll create test file, that is test.txt. Currently, these files are clean with no data. Now I'm creating one counter starting with 1, and then we will we'll get the remainder through a basic command, that is round, and divide it with the %test. This is our test index. Using this test index, we'll check if this particular file will help, like this, but after each fourth file, it will be divided giving 1. So we will set that, give the path of that particular file to test.txt. So for image in globe.iglobe, same as os.listdir, os.path.join, you have to give the path of your main directory. Inside that, you have to read all the PNG files, because inside dataset you have PNG as well as the text file. So we will only read PNG files. So star means all the PNG files. Now we have the name of the images in this variable. Let me check. So you can see it is having the path dataset / the name of the image. Now we only need this name of the image. So what we will do, we will use the split function. os.path.split text. os.path.base name from image. When you print it, so you can see it has splitted the complete name in 3 parts. Dataset / in was first part, and then other 2 is name of the file, and .png is the extension. Then what we will be doing, we will be checking if count is equal to And another thing that this split text earlier we have printed, we'll store value. It will return you two things. One is the index. The other one is the, like, 0 is the name of the image and this is the extension. So accordingly, name and ext. So if count is equal to our index, what we will do? We will increase the count by 1, and then if it is same, we will store the name in test file. Test file dot write. It will be having the path. So dataset slash name of the image. Name plus dot png plus. So we have to save it like every time we have to write in a new line. So slash n. Then we will write else part, else train file dot write dataset slash name is suppose this crested auklet dot png and next line. And again, we will increase the counter. So let me run it. If it is executing successfully, then we will check whether the files have been created or not with the name or path of the images. Then I'll copy the code. So I go inside data folder, sort it with the last modified. Till now, it has not created the train.txt and test.txt. It takes some time to reflect the results on the drive. Let me check it from here. Day 10, darknet. And then I'll go to data folder. So you can see train.txt is there. Test.txt is there. All of you, please run this code. If you are finding it difficult to write the entire code, I have already shared with you this complete notebook, which is having the code. You can copy the code from the shared notebook, and then you can use it. Just copy the code from the shared file and you can use it. In my case, train and test files are there now. You can see train.txt, test.txt. When you are successfully able to create these files, make sure your file size should not be 0 KB or 0 bytes. Otherwise, it is not able to write anything in the files. You can see it is having the path of each image, which will be using as training part, and the second is the images with the path of the images for testing. So there is only one file. That means it is writing in the other file. So let me tell you how many images are there. Length of OS dot list dir, then data set. So $1093 total files are there, and some the half of the files are PNG files and remaining are the text files. So 500 something images are there. 547 something. I don't know why 3 is there, or it is not able to read all the images. When you are done up to this part, please let us know. Please report in the chat box if you are able to do up to this particular part. So let's wait for a couple of minutes so that also you can do the same. Now it is correct. So all of you, please make sure you are using count is equal to 1. You are resetting the counter when you are writing the file in the test file, because earlier I was getting only single file name in the test. So when you use count is equal to 1, then you will be having the correct code. So now we have created two files. One is train.txt and one is test.txt. Train.txt will be having your train file, name of the train images, and test.txt will be having the name of the test images. After that, I will comment these lines. So I think now we can go ahead with the other part because it will take some more time. So there is a question why we are not using train test split directory here, because we are not writing our own code for training. The YOLO configuration is like that. You have to only give the name of the images. You can do that manually, like or also train test split. You have to read the image names, then you have to give it to it in the form of data frame or numpy array. That also you can do, but you have to create the configuration file such that it will be having two separate files with the path of the images. One is train.txt and one is test.txt. After that, you have to create three more files. Up to this part, you have created two files, train.txt, test.txt. Next, you have to create three more files. One is the configuration file, which will be having the YOLO configuration, the network architecture of YOLO v4 for your custom dataset. So, and other two are the, one will be having the names of the classes in which your data belongs to. And the third one will be having the other configuration, like where you want to save the weight, where is your names file, and where is your configuration file. So in the when you will go inside the darknet and go to CFG folder, this CFG folder, there are various configuration available. You can see YOLO V7X is there, YOLO V7, V7 Tiny, V4. So we have to download YOLO V4 custom. Just download this file, YOLO V4 custom. From CFG folder, download YOLO v4-custom.cfg. I'm renaming it as birds.cfg and then opening it. Please download this file and open it. You have to make changes in this file. Some 4 to 5 changes are there that you have to make. And then your network architecture will be ready for your dataset. It depends on the number of classes you have in your dataset. This configuration file is for COCO dataset, which is having 80 objects. COCO 80 object class object detection problem. This is the file, but you have to make changes in a way that you can fit it for our objective, that is classify object detection for 10 classes word. So the number of classes are 10. First of all, make sure your batch size is 64, subdivision is 16. Then you will find out height and width. So it should be multiple of 32. 608 is also okay, but I'm setting it as 412. Height and width. Then when you'll go down, you will find out, first of all, make sure batch should be 64, line number 6. Then subdivisions should be 16. This is line number 7. Make width is equal to 412. Height is equal to 412. Line number 8 and 9. So till now 6, 7, 8, 9. 4 lines you have checked. Next is maximum batches. So as it is for COCO dataset, there are maximum batches as 500. So it depends on, like, maximum batches are the number of batches, maximum batches you want to define for a particular iteration. After that, it will be stopping. So in our case, the formula is your maximum batches should be number of classes multiplied by 2000. But if your class is 1 or 2, it should not be less than 6000. The minimum value of maximum batches, minimum value for maximum batches is 6000. But as we are working with 10 class, so the formula for maximum batches is number of classes multiplied by 2000. So for our objective number of classes are 10. So it will be 20,000. Maximum batches as 20. Line number 20. Set maximum batches as 20,000. After that, there is another change, that is steps. So it is 80%. Steps is 80% and 90% of 80% and 90% of maximum batches. So here, accordingly, you have to set the steps. 80% of 20,000 and 90% of 20,000. So it will be 16,000. And then the other one is 18,000. These are the changes you have to make. 2 more changes are required. Steps will be 16,000 and 18,000. If you are not able to get the things with my flow, you can read it from the chat box. I have just write it down, whatever changes you have to make. Line number 6, 7, 8, 9, then 20 and 22. Then you have to search for classes. As the file is for COCO dataset, it is having classes as 80 in the YOLO layer. You can see 967 is the YOLO layer starting, and 970 is the number of classes it is defining. So in place of 80, you have to write at 3 places. Line number 970, 1058, and the third is 1146. At 3 places, make classes is equal to 10 at 3 places. One more change and then your configuration file will be ready. Whenever you are searching for classes, you will find out this is our YOLO layer, the output layer of the YOLO. And just before that, number of filters are 255. You have to make the changes in the filter. So the formula is, as explained by Vibharti sir in the theory class, you have to give it with the number of classes and the annotation, because 5 is the elements we have in the annotation file. So accordingly, the formula is number of filters will be classes. Let me write it in the chat box. Classes plus 5 into 3, because 3 boxes it will be predicting. 3 anchor boxes with ratio 1:1, 1:2, 2:1 is predicting. So that's why I multiply by 3. So here the filters will be 10 plus 5, that means 15 into 3, 45. So search for classes, make in place of 255, make it 45. Line number 963. Make sure you are searching for classes and making changes just before the YOLO layer. 45, one change. Second change will be 1051. Line number 1051. And third change will be line number 1139. These are the changes you have to do. At 3 places, make classes as 10. At 3 places, make filters as 45. Line number 1139, line number 963, and line number 1058. Now your configuration is ready for 10 class dataset. The formulas are also written in the shared Python notebook. If you want to go with the custom data set, which could be even having 1 class, 2 class, or even 100 classes, accordingly, you have to make the changes. The basic concept is the same. You have to use the same formula, but the values will be varying as per your data set. Okay, till this part you have done. Line number of filters. Okay, I'll repeat it. First of all, you have to make filter line number 963 for filters. 963, 1051, 1146. 963, 1051, 1146. Now save this file. You have to create 2 more files and then we can start the training. The first file is the names file that will be having the number, the name of the classes. I have already, I think, created here. So I'm just pasting it in the chat box. These are the name of the classes in your data set. The first class is black-footed albaster, then brewer blackboard, and some 8 more classes are there, which we are using. Just create a new file, bird.names. I'm creating a new file, saving the content. With the name bird.names. This step also there in the shared folder. the Python notebook, you can copy the name from the shared file. Just open the YOLO V4 word detection file. All the names were already given in the shared file. You can go through the steps. Step number 8 is there. You can go through that and just copy paste the name. The third file is data file that you have to create. It will be having 4 important things. The first 5 important things. The very first is number of classes. So make classes as 10. The second line is path of your train file. So train is equal to data slash, our file is in data folder. So data slash train.txt. Next is the valid.test file that is there in data slash test.txt. The third is names file that you have created. That again we will upload inside data folder. So data slash word.names. And then backup is the parameter that you are passing where you want to save the intermediate weights after training. So in initial iteration, YOLO will be saving after each 100 epochs or 100 iteration. After each 100 iteration, it will be saving the weights. After completing 1000 iteration, it will be saving the weights for each 1000 iteration. Like that, it will be doing. So please create these 3 files, word.cfg, word.names, and word.data. So word.cfg you have already created. Next is word.names you have to create, and word.data. Make sure extension is correct. It should be names. When you will be ready with the files, please let me know so that we can go ahead with the training part. I will share with you all these files which we have created. Participants, are you able to follow the things? Please let us know. Whenever you will be ready, we can go ahead with the training. Okay, if you are ready with the data, let's upload the files. First of all, in the CFG folder, you have to upload the CFG file. Click on file upload. I have the CFG file in downloads folder. Words.cfg I have created. Give me a minute. I'll delete something from my drive. Meanwhile, you can upload it. Just upload the CFG file inside CFG folder. Inside darknet, there is a folder CFG. Upload your birds.cfg file here, or whatever name you have given. Now go to data folder. Other files you have to upload in the data folder. File upload, and then bird.data and bird.name. Two files you have to upload here. When you are ready with the uploading, please write it in the chat box, uploaded. So what we have done, we have cloned the darknet, make the required changes in the make file, create the configuration build. Then you have created after accessing the dataset, you have created the train.txt and test.txt files, which will be having the name of the or path of the images for training and testing. And then you have created 3 more files. One is the configuration file that will be totally depending on the number of classes in your dataset. The second one is the dot names file, which will be having the class names in it, separated by new line. The third is the dot data file that will be having 5 lines. The first one will be the classes, then path of your train.txt, path of your test.txt, where is your names file, and where you want to save the intermediate weights. Up to this part, if you are able to do, then you are good to go for training. So because we are using transfer learning approach, we have to first of all access the trained weights of COCO dataset that you can download or access through this darknet. I'll share the link as well. So let me first of all access it. YOLO v4.on.137. So this is the link of our drive, the shared drive of the official weights. (404). Let me try with other command. Wget. Releases // I will paste the link and I will be ready with the complete path. Okay. So this is the link through which you can download either you can download it and upload it, or using wget command of Linux, you can download the pre-trained weights of YOLO v4. Just run wget space the link. You can open the link by clicking on the chat box and then copy the link from there instead of typing. Now, after running wget, just comment it, and then we will start the training. So for training, one file is there in darknet folder, one file. This darknet is there, a Linux-based file that is having all the predefined functions available that you have to run. So the first of all, you have to access the file. So /darknet, because the darknet is in the current working directory. Space, you have to pass first parameter as detector. Then because you are training, you have to write train. Then you have to pass the path of your data file. So our data file is inside data folder, data/bird.data. Then you have to pass the path of your configuration file, that is inside cfg/birds.cfg. There are chances that you have created cfg file with name bird. So make sure your file name and path should be correct. Then you have to pass the downloaded weights. Just now you have downloaded YOLO v4.con.137. And then because you are working with collab environment, it will not pop up anything. So you have to pass the parameter as don't show. Otherwise, it will give you error because it cannot open a new window. If everything goes well, it will start the training. So first of all, let me run it. If there is no error, I'll copy the code in the chat box. So you can go through the configuration. It is using CUDA version 11, OpenCV with 4.2, CUDNN is 8.7. It is using only single GPU. Other things are like GPU name is Tesla T4. What is the batch size? And this is these are the layers from YOLO. Then I think there is any issue. So that's why it is not working. When you are stopping here, please run it. I am pasting the code. Maybe in your case, you are able to run it. But when you are stopping at this particular place, that means your train file and test files are not ready. So let me check. Inside data folder. It is not able to read the images. So you can see my test file is empty and train file is again empty. So maybe in your case, it is running properly. Let me rerun the code again, that's train and test code. Meanwhile, you can run the code in your drive. So these are the errors you will encounter when you are working with darknet. And you have to troubleshoot by yourself if you are working on your custom data, that how to make, you can see 0 bytes and 0 bytes. It was not able to write anything. Anyone whose training has been started, please report in the chat box. Are you able to run up to this part? That also you can report. So now the files are correct. I will rerun it. Please report or you are facing any issue. Now it is loading the weights. It will give you some warning while reading the images, but it will work properly. Let it start the first iteration, then I'll explain you what it is showing to you, and then we will stop the training. And I have already trained up to 2000 iteration. We will access the trained weights and then calculate or test on the new images and then calculate the mean average precision that is generally reported in the papers. I'm stopping the training here because my first iteration is completed. Then I will explain. You can see this is the loss, 20 point something is the loss of first iteration. So the background working, Viparthi has already explained. This is the average loss because this is the first epoch, first iteration. So the losses are same. Then it is telling you how much time it has taken. And for the first iteration, it will not tell you how many hours are left. But after the first, when the second iteration will be started, it will tell you the average time. When you run up to 48 hours, then your training will be sufficient. So as we don't have that much of time, I will share with you the trained weights. On these weights, you can run. Just comment or this line. I have the trained weights in the backup folder. The weights has been already shared with you. You can either download or upload, or you can access it from the shared link now we will use. So I'm going inside my official ID backup. You can see it is saving the weights for 1000 iteration, then 2000. And this is the last. So I'm copying the path of this particular last saved weights. You can stop the training. If your training has been started, please stop it. And we will check how the performance increases and loss is decreased after 2000 iteration. I have pasted the link. Please add the shortcut of this particular link in your drive. So clicking on this add shortcut to drive option, drive plus, go to the place where your darknet folder is available. In my drive, day 10, darknet, and then backup. Currently, the folder is empty because we have not trained the model. When you will train for some 100 iteration, then it will save the weights. And then add shortcut here. Now, when you will go to backup folder, you will find out this shortcut weight is there, bird_last.weights. So we will use these trained weights to rerun the same command. This time, instead of using Coco dataset, we will use the earlier used trained weights. Darknet detector train data/bird. All the things will be same, only the weights will be in place of YOLO v3 con 137. We will use the shared weights, cfg/bird.cfg, and then here we will be having backup/bird_last.weights, and then don't show parameter. I'm pasting the code in the chat box. You can also run the same. And after 1 or 2 iteration, I will stop and then I'll tell you what was the current loss. Earlier it was 2020. Now you can see the last saved weight is 2300 and the loss was 0.60. I'm stopping the training again and commenting this particular line. 2301 loss is 0.6, average loss is 0.6, and then you can see 0.56, 0.59 remaining. It will decrease when you train for some more 1000 iteration. It will be 5 or 4 hours because just now it has started. So that's why it is giving you. So all of you, please report in the chat box if you are able to done up to this part. I'm waiting for all of you to complete it. Maybe 2 minutes I'm giving you, then we will go ahead. The other thing is we have to predict on a new image, the bounding box on a new image, maybe 2 or 3 for the 2 or 3 images we will predict, and then we will calculate the mean average precision that is generally reported for object detection task other than loss. Please run these commands, and when you are done, please write in the chat box, or if you are getting any issue, any error, or unable to understand, that also you can ask. I know it's little bit tricky. Earlier, when we have started working with darknet, it took us 2 to 3 iteration to successfully run the commands. But if you will report in the chat that what is the error you are getting, then only we can help you. The ma'am, it shows could not open file. Which file it is not able to open? Can you please write the name? Whether it is configuration file, data file, or name file. Okay, make sure your name is same, like correct, whatever you have given, because earlier like, it could be bird or birds or maybe some other name you have given. Go to your CFG folder and cross check what was the name of your file. Okay, another issue is I'm not able to run this darknet. Please run this ls command to check you are in which directory. When you will run ls command, if it is showing these type of files, that means you are in correct directory. If you are in outside, for example, when you are outside the darknet folder, and then you will run the command for training, you will find out the error. Darknet is a directory. So for that, you have to go inside darknet folder. And then you can run ls command to check all the files are there or not. And now you can run the darknet detector. I think this can resolve your issue. Please go inside the darknet folder using cd command. Can we go ahead with the testing and mean average precision part? So for testing, you have to provide along with this particular command, you have to provide the path of the image for which you want to predict the label and the bounding boxes. So for example, in the darknet, I am selecting any random image from the dataset. You can also select, as per your opinion, you can select the random image, like whatever you like, whichever word you like, you can select that. So I'm using any random image, copying on we cannot rename view detail, and then I will copy the name. So you have to use /darknet in detector, in place of train, this time you have to write test and then path of your data file, path of your configuration file, then weights path. So we are using the train weights. So backup slash bird underscore last dot weights. Then you have to provide the image name. So I'm using just pasting the path. So it is there inside darknet, dataset folder. So dataset slash the name of the image and then don't show option. It will take some time for testing. I'm pasting the code in the chat box. Only in place of train, test will be there. You can see it has first of all read the YOLO structure, then loaded the weights, and then it has detected the correct class with 100% as the confidence score. And your whatever you have, like whichever for whichever image you have predicted, the final result with the bounding box will be saved inside your darknet folder. Inside your darknet folder, there will be one image predictions.jpg. When you will be opening this, you will find out one box is there on the bird with the name of the class and then confidence score. Is it clear to you all or any issue in this part? Are you able to predict it? You can go through any other image. I'm again changing the image. You can also do the same. Just change the image. So this time it is predicting another class UT Albatros with 99 or 0.99 as confidence score. And again, it will save the weights, save the prediction in the predictions.jpg file inside darknet. So this time, this is the bird with this much confidence score. You can try with other images. The last part is calculating the mean average precision. So the command for calculating the mean average precision is /darknet detector. And then in place of test, you have to write MAP, that is mean average precision, then path of the data file, path of your configuration file, and then path of your weights. And don't so, you have to write. So it is giving you mean average precision as 93.8 with IOU threshold as 50%. So you can change the threshold from 50% to any other. The precision it is giving you is 0.87, recall is 0.91, F1 score is 0.89, average IOU, that is intersection over union, is 70.32 for these images. And these are the class based performance. For which class, what is average precision? For each class, it is calculating average precision. So you can see for 2 classes, it is predicting 100%. These 3 classes, it is predicting 100%. For some classes, 81, for some 90. So for the challenging class, it is reaching minimum, that is 81 or 80. I'm copying the code in the chat box so that you can also run to calculate the mean average precision. So other than this, you can also predict for videos. It can also predict for videos. For that, you have to use, in place of test or map, you have to use /darknet detector space detect. This will be the change. And then you have to provide any video in place of image here. You can provide any video. Please write in the chat box if you are able to do up to this part. Meanwhile, if possible, I can download any word video because I don't have any word video. Otherwise, you can just use it. The command will be same. In place of test, you have to write detect. And in place of image, you have to pass the MP4. Path of your video. So it will predict on video as well. If there is any issue, please let me know. Participants, are you able to get the things? Are you able to run up to this part? That also you can report. I'm downloading a video, then we will try to run the video code as well.
Any further questions for participants? What I feel is a good that some people are continuously asking questions and interacting, but most of the participants are not taking part in this discussion. Participants, your full active participation is required. We should know that you are learning. We should know that you're enjoying these sessions. Simply attending the session, I don't know how much it's going to help you. My suggestion is that you should actually take part in the discussion. Even if nothing is clear, no problem. We will try making clear to you. Right? So your out of 100, if there are only 3-4 people, 5 people who are asking, discussing, how it is going to benefit you, my dear friends? It's not going to benefit you. So my request was, I have been requesting also before, like, please do not hesitate in asking questions. So that's what my request is. If you can take advantage of these courses, we will be running more courses of this type in future. But if you don't ask questions, then how? See, this is a physical, not physical. So we really don't have any idea. Are you learning? You're not learning, right? So with this, I request all of you to please take full benefit of it. We make lot of efforts to uh, explain you, bring things to your knowledge, many new things to your knowledge. We actually prepare a lot, and we hope that you will appreciate that if we don't get questions, so many questions are, I mean, the sessions have to be very interactive. So that's all from my side. Wish you all a very good evening. Please relax. The 4 hours I know is very difficult. I also keep attending for 4 hours. So we know that it's very time consuming and little tired. One feels tired also. So, but we expect your fullest cooperation in making these programs successful, not as a getting your good feedback. It really helps us and we feel happy, but also we should really be, I mean, you should be really able to do it in your research and teaching. That's what we want. Thank you so very much. It was I hope you will not take it otherwise, but yeah, one requires to actually take part. Okay, thank you, Poornima. Thanks all the members of the Asia Connect project team. Thanks on behalf of Professor Preeti Khanna and me. And we hope we'll be meeting tomorrow with yet another very interesting session.